This video introduces AI4CTI, a solution created by TECNALIA that leverages large language models to perform the analysis of cyber threat intelligence sources and to extract TTP data. The component is part of the AI4CYBER framework developed in the AI4CYBER EU-funded project. AI4CTI takes open-source intelligence information about advanced persistent threats type of attacks and identifies attack tactics, techniques, and procedures, the so-called TTP data, as well as the order of such TTPs and the linked mitigations related to the TTPs. The component creates a structured output so it can be used by different kinds of cybersecurity solutions or tools afterwards. In AI4CYBER framework, AI4CTI is integrated with the detection solution, and the output is used by the AI4Triage component to extend the knowledge base of known attacks to improve detection. For AI4CTI validation, different sources of APT attack information were used, including both reports of attacks, called advisories, and attack flow graphs representing those APT attacks. The particular APT attacks selected for the component validation are those relevant in the use cases of the AI4CYBER project. The attack flow graphs were created in AI4CYBER according to MITRE attack flow format, and 2 of these are publicly available in AI4CYBER GitHub. Let's open one advisory as an example to learn its contents. CISA is the American Cyber Defense Agency, which periodically publishes advisories of known attacks, and the advisories are publicly available in CISA website. The advisories explain the attack. They have a description of the advanced persistent threat attack, what kind of TTPs are used, what is the malicious group behind, what detection methods were used in the sightings, recommended mitigations, etc. So this kind of advisories are long reports with a lot of information, so they are complex to process by security experts. Therefore, AI4CTI will be used to support and help them to process this kind of reports and facilitate knowledge improvement and detection of the same or similar attacks. The goal is that OpenCTI processing gets automatic, and the output from AI4CTI is made usable by other cybersecurity tools. The Attack IQ information is another type of public report. Attack IQ is a very well-known CTI source that issues reports to respond to CISA advisories. These reports contain attack descriptions in form of attack graphs and their explanation. In AI4CYBER, we use these reports to support the creation of attack flow graphs. The attack flows of the relevant attacks in AI4CYBER use cases were created following the MITRE attack flow 3.0.0 format. The MITRE attack flow builder tool includes many examples of flows of known attacks, and all of them refer to the corresponding CISA advisory. An attack flow models attack steps or actions. Each of the actions is represented by the tactic and techniques used by the attacker in that step. The APT attack is therefore modeled as a flow of actions. The CTI processing by AI4CTI follows a workflow wizard thanks to the buttons in its graphical user interface. The first step is the scrapping step, and then the workflow continues with the steps represented in the button row. Let's explain them one by one. The scrapping starts by selecting the CTI sources to be analyzed. The URLs of the reports to process should be provided. In general, we can provide the URLs of 2 types of CTI reports associated to the attack under study, the CISA advisory and the attack flow graph. In case we have only one type of report, we can provide the URL of only that report. Then, to initiate the process, the user clicks on Press to perform scrapping, and the tool gathers all the raw text that it is available in the reports. Once the scraping is done, the graph analysis shall be clicked. Here, the location of the attack graph that corresponds to the advisory should be provided. The attack graph should be in MITRE attack flow format. These attack flows come in JSON files. This is the format that MITRE is pushing as standard way of representing an attack as an ordered graph of TTPS used. Here we have all the TTPS read in the attack flow. Once that, we have all the sources specified, the URLs of the two types of reports, or one of the types in case we only have one, as well as the URL of the graph format. The structured analysis can be started. In the structured analysis, the AI4CTI is looking for patterns of TTP descriptions in the structured text of the reports, tables, bullets, etc. As a result, for instance, in this advisory, these are the TTPS that were just identified in the CISA advisory on the left and the Attack IQ report on the right. This information can be exported to CSV format with the export buttons. Then, in the unstructured analysis step, the AI4CTI will detect the temporally ordered events using a large language model. The LLM used is Llama 3.1, 70B, and natural language processing of the text in the reports is done to identify both TTPS and the order of the TTPS. The prototype currently uses this open LLM deployed in TECNALIA's CATEA infrastructure. The tool shows the TTPS found by the LLM in the natural language text of both the CISA advisory and the Attack IQ report, and the user can also export the information as before by clicking on Export buttons. Then, in the assessment step, the component automatically creates a long knowledge graph file with all the information of TTPS found in the different 5 analysis types: attack flow steps analysis, pattern search in structured data in both types of reports, and LLM-based processing of unstructured text in both reports. The component uses a scoring system for the assessment of the TTPS. The scoring gives priority to the TTPS and their order learnt in the attack flow analysis. The main reason for this is that the attack flow is created by security experts from trustworthy information of many sightings of the attack described in the CISA advisory. The model sums to the basic score some additional points when the TTP appears also in the LLM-based analysis, and some additional points when it was also found by pattern matching in structured text. This TTP 1087, for example, was assigned a score of 13 because it appears in the attack flow, and TTP 1099 scores 2 because it appears in the LLM-based analysis. The TTP 1140 scores 8 because it appears in 3 different analyses types. In the aggregation step, for each TTP identified, the corresponding mitigations are mapped. These mitigations are searched in the MITRE attack repository, and we can also export this information. On the right side of the screen, the description of the mitigations is provided. At this moment, the tool allows the user to revise and update the TTPS and their order according to their needs. This is not automatic. The user could, for instance, remove TTPS or change their order. Finally, the user can save changes and download the assessment JSON file. This file is used by the AI4 triage component because it also can be published to the AI4CYBER framework Kafka bus. We hope you liked how the AI4CTI prototype works. Thank you for your attention, and please stay tuned with AI4CYBER in our public channels.